Ever wondered how AI models like ChatGPT or Gemini tackle complex problems? It's not magic, it's all about prompt engineering. Think of a prompt as a recipe. Vague instructions lead to random results, but precise, structured queries unlock incredible outputs. But here's the challenge. Crafting the perfect prompt is like solving a puzzle with missing pieces. That's where prompt optimization comes in, automating the process of refining prompts to maximize AI performance. Recent research reveals that even the most advanced language models struggle without carefully designed prompts. Existing optimization methods, however, have two critical flaws. First, they often generate highly similar prompts, stifling creativity. Second, tweaking a prompt for one task can unintentionally degrade performance on others, a phenomenon called semantic drift. Enter RIOT, the residual optimization tree. This framework tackles these issues with a tree-like structure where each branch represents a unique prompt. At every step, RIOT generates diverse prompts with distinct semantic meanings, like exploring multiple paths in a forest. It then selects the most effective one using perplexity, a metric that measures how surprising a prompt is. The more surprising, the better it tends to work. But here's the genius. RIOT doesn't discard old prompts. Instead, it uses text residual connections to preserve the useful elements of previous iterations, like keeping the best ingredients when refining a recipe. This prevents semantic drift, ensuring improvements for one task don't break others. The results? RIOT outperformed both traditional methods and human-designed prompts across 5 major benchmarks, including math problems, logic puzzles, and code generation. On one test, it boosted accuracy by 4.6% compared to the best existing method. Why does this matter? RIOT makes AI more reliable and adaptable. It's like giving AI a smarter toolbox for problem solving. Whether you're a developer, researcher, or AI enthusiast, this innovation brings us closer to systems that truly understand and adapt to our needs. Want to see how it works? Check the description for the code link. And if you enjoyed this deep dive, hit subscribe for more insights into AI's cutting edge. Let's break down how RIOT actually works. Imagine training a language model to solve logic puzzles. Traditional methods might feed it raw text, hoping it spots patterns. But RIOT takes a different approach. It generates prompts with explicit rules. Think of it as giving the AI a GPS, clear task definitions, constraints, examples, and even predictions about potential errors. This structured approach outperformed GPT-4 in tests, achieving 61.4% accuracy on logic puzzles versus the model's lower performance. Why? Large language models often ignore parts of their instructions, like a student skimming a test. RIOT's method acts as a step-by-step checklist, eliminating shortcuts. But here's the trade-off. While AI-driven methods are simpler to deploy, RIOT's structured prompts are more precise, though harder to set up. It's like choosing between a sleek modern car AI and a meticulously tuned machine, structured prompts. Both have their place. So what's the takeaway? Sometimes old-school techniques still shine. RIOT proves that even with cutting-edge AI, clear, structured guidance can outperform raw model power. It's a reminder that the smartest systems need the right roadmap to reach the right answers.